welcome to PIQ'S TV under General Physics 2. This is me, your host, Dr. Glenn Michael Jameson B. Piquero. Alright, welcome to another session in our Physics 2 lessons. This time we are now focusing on the special theory of relativity, introduced by Albert Einstein again in 1905. This revolutionary theory changed our understanding of time and space, showing that they are not absolute but relative and interdependent. The special relativity is based on two fundamental postulates. The first one, the laws of physics are the same in all inertial frames of reference. Second, the speed of light in a vacuum is constant and will always be measured as approximately 299,792 km per second, or in our calculations it's 3.0 times 10 to the 8 meter per second, regardless of the motion of the source or observer. Let's now talk about time dilation, which is a special phenomenon connected to the special theory of relativity. Time dilation is a phenomenon where time, as measured by a clock moving relative to an observer, appears to pass slower. Let's take a look at a sample problem here. Our problem here, calculate the time dilation effect for an astronaut traveling at 90% of the speed of light for a journey that takes 10 years according to clocks on Earth. Let's use the time dilation formula. T prime is equal to T over square root of 1 minus the square of the speed, V squared over C squared. 90% yun. Yung V squared is 90% of the speed of light. So, can be 0.9 times 3.0 times 10 to the 8 squared ulit over 3.0 times 10 to the 8 squared. Where T is the Earth time, V is the velocity of the astronaut, and C is the speed of light. Try to use this formula, show the given as a solution, and show the final answer in your physics notebooks. Let's now go to another phenomenon connected to special relativity called length contraction. Length contraction occurs when the length of an object moving at a significant fraction of the speed of light contracts along the direction of motion. Let's now solve a related problem. Calculate the observed length of a 100-meter spaceship as it travels at 80% the speed of light relative to an observer. Use the length contraction formula. L prime is equal to L times the square root of 1 minus V squared over C squared, where L is the rest length and V is the velocity of the ship, which is 80% of the speed of light. So 0.80 times 3.0 times 10 to the 8 meter per second. So over 3.0 times 10 to the 8 meter per second squared again. Then 1 minus the whole expression b squared over c squared. Then take the square root there and times the original length, 100 meters. So you will get the contracted length. Try to show the given as a solution on your notebooks. The reason why I'm not showing the full answers is for you to have your practice on your notebooks using this particular formula for length contraction and time dilation. Okay, let's now talk about another phenomenon called the twin paradox, Kambal. The twin paradox is a famous thought experiment in special relativity where one twin travels on a high-speed journey into space while the other remains on Earth. Upon returning, the traveling twin is younger, which is a real-life consequence of time dilation. Relativity of simultaneous or simultaneity. This concept states that events perceived as simultaneous by one observer may not be simultaneous to another observer moving at a different velocity. This shows how individuals moving at different velocities can disagree on the timing of events. And maybe in movies and even in other video lessons like this, there are some demonstrations about the relativity of simultaneity, especially when discussing about the concept of the multiverse in the Marvel universe and in even DC Comics, there are multiple universes. And lastly, pertaining to E equals mc squared or the mass energy equivalence, this is Einstein's famous equation wherein energy is equated to the product of the mass then the speed of light or the square of the speed of light expresses the idea wherein mass energy or the mass energy equivalence, it shows that mass and energy are interchangeable and that a small amount of mass can be converted into a large amount of energy, which is foundational for nuclear physics. The special relativity has profound implications across physics, affecting everything from the fundamental workings of the universe to practical applications like also another GPS satellite technology, which must account for the relativistic effects to function accurately, especially the atomic clocks. And basically, that's the second to the last part of our lesson for today. Okay, we are now at the end of our video lesson. Just like our previous video lessons, we have our own exit cards. Just write the things or conclusions about what you have learned about the topic and also what questions are you going to ask the teacher. You can post this in the comment section of our YouTube video. Laging tandaan, sa PIQ'S TV, panalo ang natuto.